Good morning, students. A very warm welcome to the SBR online PU classes. Okay, let me introduce myself. My name is Ravikumar Solomon. Okay, and today I am here to discuss here the new topic permutations and combinations. Okay, so shall we begin? So today it's a chapter number 7. Okay, and the topic name is permutations and combinations. So don't worry, students, by reading the name of the topic. Is that clear? So don't worry. We will simplify this in a more simple manner. Okay. So let's discuss this. So before we get into the topic of permutations and combinations, let's question ourselves. Let's question ourselves. Why do we need to study this topic? Okay. So this topic is not only important just to score marks, okay, but we also need this topic to study some real life problems, and come at a solution for those problems in our life. Okay, so it's not just important for the to score marks, but also we can solve our day-to-day life problems. Okay, so it will be easier if we understand with some illustrations, examples, or scenarios. So firstly, okay, now what is permutation? Okay, students, what is permutation? If I tell you a more simpler meaning of permutation, easily you can understand. But before introducing that name, before introducing a very simple name, so let's take some questions. Or let's ask ourselves some questions, or let's discuss some examples. Okay, so first one, we shall take the example of a library. So let it be your school or a college library. And I believe that everybody has seen or visited a school library or a college library, right? So you visit a school library or a college library. Yes, students. So you go to the library, you ask a librarian, to give me a particular book. Right? So you're asking the librarian to give you a particular book. It might be physics or of chemistry or of maths or of biology or even languages. Okay, is that clear? So if you have seen the library, you can surely come across lakhs of books together, right? So in those lakhs of books together, you ask for a particular physics subject, okay? But have you seen the librarian? Within no time, he goes to a particular shelf, okay? So he goes to a particular shelf or a cupboard or a rack, right? And he hands the book to you within no time. Is that clear? So why is it so easy for him to do so? Okay, so let's question ourselves. So why is it so easy? And in case if we ourselves go and find that particular book, we may not find it in a very short period of time. We may take a lot more time than the librarian. Okay, so why? Because the librarian, what he does, that he arranges the books, for example physics, into a particular shelf. Okay, so and chemistry he arranges in another rack, mathematics in another rack, and biology in another cupboard. So you might have observed or heard me saying arrange, right, students? So what does he do? He arranges books according to the subjects. So I am introducing a word. It's not a new thing, but it's required. It's the most required word, right? So in this topic, and you can even see their physics are arranged only in one cupboard in some order. Okay, so if you consider physics, so first cupboard, he may arrange the theory books. In next cupboard, he may arrange JEE physics books, and in next cupboard, he may arrange JEE NEET books. You won't find the JEE books in NEET rack or NEET books in the theory rack. Okay, so in some order, okay, in some order, he is arranging the books. So that's why it's very easy for him to go to a particular rack within no time, because you're not only the one student waiting for to pick the book, right? There are thousands of book to get. There are thousands of students waiting in line to take the books. So to simplify this, the librarian applied here permutation thing. So by permutation thing, what do we say? Arrangement of objects or things in some definite order only. Okay, because physics books, if the cupboard says cupboard is named as physics, and in that physics cupboard chemistry books are there, biology books are there, maths books are there, all are kept. So it is nothing but a haphazard manner. Okay, it will be totally a mess. Even the librarian cannot search a particular book in that case. So that's why a definite order, a definite set of books has to be arranged in a definite cupboard only. So permutations means arrangement of objects in some definite order. Okay, so is that clear? So hope so. This example is clear to you all students. So we will take one more example. Okay, one more example, the one which you are holding in your hand. So that's your latest gadget, that is your mobile. Okay, and as you all know, in this, due to the pandemic, so everybody is on the mobile for the classes, right? So I believe everyone has a mobile, right? So everyone has a mobile now, right? You won't live as it is. So you definitely have a lock code to this, right? Okay, so it may be some pattern, or it may be a face lock, or it may be a fingerprint lock, or it may be a lock code, and the lock code may be the number, right students? Okay, so if the mobile has to start or to unlock, right, you have to input some digits, right? You have to input some digits so that you can use the mobile, right? So let us suppose that it's a 3-digit pin, right? Similarly, you have in a ATM card also, right? Similarly, you have a password for your Gmail accounts also. Is that clear? So let's begin with the mobile. Okay, so mobile, so it has a 3-digit pin, a number pin, right? And I will tell you the code comprises of 3 digits. So 1, 2, and 3. Right? You don't know what is that code. Okay. So that to unlock the mobile, you need 3 digits. That is 2, 3, or 1. Okay. So how you can think of ways of adding the lock to this mobile. Okay, so let me write some ways. So you can keep the password as 1, 2, 3. Okay, or you can keep the password as 1, 3, 2. Is that clear? This is also one way of keeping the password. This is also one way of keeping the password. Okay, and it can be 2, 1, 3 also, right? It can be 2, 3, 1 also. Is that clear students? Are you understanding what I'm trying to tell here? Okay, so it can be 3, 1, 2 also, right? And it can be 3, 2, 1 also, right? So I have given you 3 digits, 1, 2, and 3, and I am asking you to keep a lock code only comprising of 1, 2, and 3. Is that clear? So first pin will be one number, either it will be 1, or either it will be 2, or either it will be 3. then the rest you can arrange it. Okay, so how many ways are there to unlock this phone? 1, 2, 3, 4, 5, 6. Is that clear? So in this, let me say you have picked 213 as your lock code. 213 has your lock code. So that means the first number that has to be entered is 2. The next number to be inputted is 1. And the next number to add is 3. Then only your particular mobile unlocks it. Okay. Even though 1, 2, 3 is also choice. 132 is also an option. 231 is also an option. 312 is also an option. 321 is also an option. But it doesn't open. Okay. Or it doesn't unlock. It will be unlocked only when if you input 213. Because to my mobile or your mobile, what I have told you, to input or code 213 only. So this you can see it's an arrangement, right? I have given you a bunch of 3 numbers, right? I have given you a bunch of 3 numbers and I have asked you to put a lock to the mobile, right? So our lock code is 213. So that means first I have to input 2, then 1, then 3. So it is this connection is arranged in some definite order only. Definite order only. This is important. Okay. Why? Because the mobile lock code is 213, right? And you can see there are another 5 lock codes. If you input, the numerals are same, 1, 2, 3 only. Okay. But if you input only in the first place 2 and in the second place 1 and in the third place 3, then only the mobile unlocks. Otherwise, though we have the same numbers, it doesn't unlock. So here we are not going to find out, we are not going to write down all the arrangements. Just we are going to study how many ways we can or how many possibilities are there. Okay. So I hope this is understood. Okay. So now this is your permutation. So permutation, what we have understood? Permutation is nothing but arrangements. Nothing but arrangements in some definite order only, right? To unlock the phone, the order is 2, then 1, then 3, then only the mobile unlocks. Is that clear, students? Now let's see what do we mean by combination. Okay, students, what I have told you in the beginning itself, I'll give you a very simple synonym word for the permutation. So now what is that? It is arrangements in some definite order. Is that clear? So it's easy now. Permutation is nothing but arrangement of objects or things in some definite order, as in case of library or in case of a mobile or in case of a departmental store also, right? If you visit a departmental store, you can see cosmetic products are on one side, food items are on one side, right? And milk products are on one side, right? So they are arranged in some order, a manner. Okay. Now next, what is combination? Okay, students, this is also very easy. So let's begin with the example. It will be more clear to you. So imagine we are preparing a fruit salad or a juice. Is that clear? Imagine we are preparing a fruit salad or a juice. So let me give you some fruits. Okay. So those are apple, oranges, grapes, pineapple. Is that clear, students? So, what is the task given to you? The task given to you is prepare a fruit salad out of it or a juice. Is that clear? So what do you do? Right. So you take a container or tell that this is a jar of a mixer grinder. Right. So let this be a jar. Right. To prepare a juice, what do? You are we are asking you to make a juice out of these objects or these things or these fruits. Is that clear? So objects given here are four objects, and those are some fruits: apple, oranges, grapes, pineapple. You can take banana also, whatever you want. Okay, whatever you wish to have. Okay, so now to prepare this juice, what do? You add an apple here, right? You select an apple and drop it into the jar, and then you select an orange and drop it into the jar, then you select grapes, then you select pineapple. Is that clear? So see, it doesn't it here, it's nowhere required or necessity that apple should go into the jar first only, orange should enter second only, and grape should enter third, and pineapple should enter fourth. Okay, so if you add orange first, grapes next, and pineapple next, and apple next, also doesn't matter, you will get a juice, right? And or if you put grapes first, then orange, then apple, then pineapple. Also, you will get a juice out of the four fruits. Is that clear? So, what you can see here is that order doesn't matter. You will get the end product anyhow. Right. So permutation and combination depends upon the scenarios, depends upon the examples given to you or the task assigned to you. So what is that task asked here? To prepare a juice. Okay, you pick four fruits. Okay, you put into the jar in any random manner. The end product, you will get a juice of all the four ingredients. Right. Either you put orange first, apple first, or pineapple next. Is that clear? So here order doesn't matter. Just selection of objects, just you're picking objects or you're choosing objects here. So combination is nothing but just a mere selection of objects, and it doesn't matter in which order you use it. Okay, so does not order does not matter here. Is that clear, students? Okay, so this is a good example of the combination. Or one more also you can see. I think your mother might have forced you to do that, and in spite of you not liking it, you have to obey your mother's instruction. Right? It's nothing but drinking milk. Right? Okay, so here to prepare this, either you can add milk first into the glass or sugar second into the glass, right? Or, okay, this is your glass. Either pour milk first, right, and then sugar, right? Or either pour sugar first and then milk. Okay, this combination, right? So this combination is nothing but just selection. Okay, you have taken a glass, you added sugar first or the milk first, or you have added the milk first or a sugar first. So what you are doing, you're picking milk, right? Or you're choosing milk, or you can even say you're selecting milk, right? Then you are going to select sugar. If a taste matters, if you like a chocolate drink, you can add a chocolate into that. Sorry, I was going to write boost, or you can add a boost into that, right? So the or add in the glass, add first boost itself, then sugar, then milk. So what I am trying to tell you that the order does not matter in this set of experiment, right? So, or in this set of task. So when order does not matter, it's nothing but a combination. It's just selection. You're just picking Bombita, you're just picking boost, you're just picking milk, you're just picking sugar in any manner. Is that clear? So this is nothing but combination. So we have understood the synonym terminologies to the words permutations and combinations. So permutations are nothing but arrangements and combination is nothing but just a selection. Here order doesn't matter. Here order is very, very important. Okay, students. Okay. So now let me introduce you to the topic permutations and combination. Let's go a bit deeper. Okay. So before that, let's see the blueprint of this topic. Okay. So for theory, 1 marks. Okay, in the 1 mark section, one question is definitely asked. Okay, and in 3 marks section, there are no 2 marks here. 3 marks section, one question is definitely asked, and 5 marks. 5 marks also, one question compulsory asked. Okay, so total number of marks that you can score here is 9 marks. Is that clear? So one question, 5, 3, 1. It's total 9 marks. And in case of KCET, right? So one question is definitely asked, and sometimes two are also asked, and each question carries 1 marks. Okay, CET each question carries 1 marks, and for JEE, okay, the trend we have observed in JEE from the past 5 years is that compulsory one question is asked based on compulsorily. Okay, one question is asked on the topic permutations and combinations, and in JEE each question carries 4 marks. Is that clear? Okay, so this is just a blueprint of the various competitive exams that you will come across. Okay, students. Okay, so every topic starts with some fundamental basics. Okay, so or some principles or some idea. So let me introduce to that. So you need to understand these principles very carefully. Okay, then only permutation and combinations will be very, very easy. So first, let me introduce you to the concept fundamental principle of counting. Okay, so don't worry, it's very easy. Counting. So why counting? Because here we are just counting the number of things here, or the arrangements, or the objects that we are given here. Or okay, it depends upon the task assigned to here. So every permutation and combination question, you should understand the questions very carefully, so that you will understand where to arrange the things and where to just select the things. Okay, so but before that, there are some basic principles that you need to understand, and let's begin with the concept that is fundamental principle of counting. Okay, and it's further subdivided into two things: addition principle, second one, or it doesn't matter, multiplication, multiplication principle. Okay, these two things are very, very important, okay, to start permutations and combinations. So better we shall understand these two principles on based on the examples. Okay, so now let us suppose I give you, okay, so some three shirts, from three shirts and two pants. Okay, so just imagine that I have given you three shirts and two pants, and the task I am assigning to you is now pick, understand the question here, what I'm trying to tell you, pick any one item. Okay, so the question I am assigning here is pick any one item. Okay, so how many objects? So how many things do we have here? Three shirts and two pants. So let me say the three shirts are S1, S2, S3, and all are different shirts or of different colors, you can say, and two pants P1, P2, right? So I have three different shirts and two different pants, and the task I have assigned you to do is pick any one item. Okay, why I am stressing upon this, you will understand more clearly when I take the multiplication principle example also. Okay, so now we have three shirts and two pants, and to pick any one item among this collection, so I'll pick either S1. Okay, so there is a bunch of three shirts and two pants. Okay, so now you are asked to pick, so either you will pick S1 or you will pick S2, right? Or you will pick S3, okay, or you will pick P1, because we are asked to pick only one item. You cannot pick all the items here, or P1 or P2. Okay, so how many options do you have for yourselves to pick? You have five options. So one shirt, this one, and S2, S3, P1 and P2. So how many options or collections do we have to pick one item? We have three shirts and two pants. Okay, so how we can write it down in the addition principle? Okay, so for shirts to pick, how many ways do we have? Three ways, right? Three different shirts, right? So by this you have understood that we can pick five, okay, five different ways. Okay, so let's suppose there are five students. Okay, one has picked S1, another will pick S2, S3, P1, P2. So there are how many ways? Five ways, right? So to pick shirts, he has three ways, and to pick pants, he has two options or two ways, right? So it's nothing but how many options he has? Three ways plus two ways. So he can pick a single item. A student can pick a single item among the bunch of five objects in five different ways. Okay, he can take home the shirt one, or the shirt 2, or the shirt 3, or the pant 1, or the pant 2. We are thinking about how many ways he can pick, not which one he is taking to the house, okay, or not which one he is taking. with him, right? We are just thinking about the number of ways he can pick one item out of the three shirts and two pants. So that's nothing but shirts can be picked in three ways, either S1 or S2 or S3, and pants he can pick it in two ways. So there are total number of ways are five ways. So this is nothing but our addition principle. Okay, so always remember wherever or comes, so definitely we need to use addition. Okay, and let's see multiplication principle. We shall go with the same example. Okay, that you will understand the difference. Okay, again I give you three shirts and two pants. Okay, so let me frame a question. A boy has three shirts and two pants, right? In how many different in how many different different pairs of shirts and pants he can dress up with. Okay, so understand the question here. The objects are same. There are three shirts, right? And there are two pants. Okay, but the task is changed. The event is changed now. A boy has three shirts and two pants. In how many different pairs, understand here, in how many different pairs of shirts and pants he can dress up with. Okay, dress up with. Okay, so if he has to dress up, okay, he has to wear a shirt and a pant also, then only it's called a dressing up, right? Is that clear? So a boy, if he has to complete his dressing, the event or the experiment or the operation here is dressing up. Okay, so he can dress it. So the complete dressing is nothing but wearing a shirt and as well as a pant. Is that clear, students? So this is our boy. So let's suppose this is our boy and he has three shirts in front of him. Okay, he's dressing up for a party, and there are two pants in front of him. Always we have a confusion before we go out, or if we go out to a picnic or a party. Okay, the dressing is important to us. Okay, and the right set of pair is also important to us. So we can pick anything according to our taste. So let's suppose he has picked the shirt one, right? He is wearing now shirt one. Then he can choose either the pant one, right? Okay, so he can choose the either the pant one or the pant two. So he can wear the first shirt either with pant one or pant two. So what is that set of pair? S1 P1, S2 P2. Okay, shirt one, pant two. Is that clear? So now let's suppose he has picked the shirt two. Okay, so he has picked the shirt two. So he will pair it with pant one, right? And he will pair it with pant two, right? So what is the pair here? S2P1, S2P2, right? And let's suppose we don't know. So here we are not thinking about what he is going to wear. Understand, students? We are not worried about what he is going to wear. We are just worried about in how many ways he can dress up himself. Okay, in how many ways he can dress up himself. So let's suppose he has picked the shirt 3. So he can wear it with pant 1 or he can wear it with pant 2. And that pair will be S3P1 and S3P2. Okay, so now how many different pairs he can use? This is one pair, second, third, 4, 5 and 6. Okay, so what I'm saying here, S1P1 is one pair and S1P2 is one pair and S2P2, sorry, S2P1, S2P2, S3P1 and S3P2. Okay, so how many ways are there here for him to get dressed up? 6 ways. Is that clear? And what was the question of the previous addition principle? Pick any one item. Pick any one item. So the boy could pick either from the shirt or either from the pant. Look here, pick any one item. So if he had picked shirts, there is no need of picking pant. Is that clear? If he has picked pant, right, there is no need of picking shirt because they are just asking us to pick only one item. Okay, so how many such ways he can pick one item? 5 ways. But the same question, if I frame it in this way, in how many different pairs a boy can dress up, means how many ways we are getting, in how many ways he can dress up. Shirt one with P1, P2, second shirt with first pant and the second pant, the third shirt with first pant and the second pant. So how many ways? 6 ways. Okay, so the question here is dressing up. That means after wearing the shirt, he has to wear the pant also. That's a complete event. Okay, understand you. So wearing shirt and a pant together, both events are happening here. But in the previous example, pick one item. If you pick shirt, that's enough. One shirt, that's enough. If you pick one pant, that's also enough. But in this case, dressing up means he has to wear a pant and also a shirt. Means wearing pant is also one event and wearing shirt is also one event. Then only the complete understanding of dressing up makes a sense. Okay, so how many such ways are there? 6 ways. Okay, so to pick to pick shirts, so how many ways he has? 3 ways, right? Still the event is going on, still the event, and he has to wear, understand here I'm saying, and he has to wear a pant also, and means always multiplication. So and he has to wear a pant also, that is 2. So 3 into 2 will give you 6 different ways or 6 different pairs of shirt and pant. So this is nothing but our multiplication principle. Okay, so that's why I have told you in the beginning itself, you need to understand the question properly so that it will be easier for you to either use the permutation or either use the combination. Okay, so and in that we have studied multiplication principle and additional principle. And multiplication principle and additional principle, we have taken the same objects, three shirts and two pants, but the task given, the event given or the operation given is different. Okay, so let's define them now. Okay, multiplication multiplication principle. Okay, the definition is if an event can occur in if an event can occur in m different ways and following which another event can occur in n different ways. Okay, so let me remind you the example. So what was the event mentioned in the example? So let's suppose this event was shirts. So to pick the shirts, so we had how many options here? Three. In general, I'm defining a thing, so we have to write in general terms. Okay, following which means after wearing a shirt, he has to follow up himself with a pant. So that next event is pant, wearing a pant, and can occur in n different ways. So how many objects was given over there? Two pants. Is that clear? Then total number of occurrence of the events is m into n ways. Okay, with the example is what is m here? Shirts, regarding shirts event 3. So after wearing shirt, he has to definitely wear a pant also. Then only it is called a dressing up. So the event is going on into pant. So how many pants? 2. So 6 ways. So this is the definition of the multiplication principle. So let me write it this above. So the numerals what I am writing is regarding the example. Okay, so this is our multiplication principle. Now next we shall write addition principle. Okay. Okay, so addition principle. So let us define this. If there are two operations, or you can even also call events such that so what was the example given? The example was given 3 shirts and 2 pants, but you have to pick only one item. So if there are 2 operations or events such that they can be performed independently in m and n ways. Independently, they are not depending upon each other. So what was the thing I have given you as an example? So 3 shirts, 2 pants. Okay, so the question was to pick one item. So if you had picked a shirt, there is no need of picking a pant. That's it, over, right? If you pick a pant, there is no need of picking a shirt. That means in this question, pick one item. Their shirts and pants are independent of each other. They need not come together. But in case of another framing of question, dressing up, to dress up, he has to wear a shirt and a pant also. Then only that's a complete dressing. Okay. It all depends upon the understanding of the question. Okay, in M and ways respectively. Then either of the two operations, then either of the two operations can be performed in m plus n ways. Okay, so there were three shirts. Sorry, there were three shirts, right? And there were two pants. To pick one item, how many options we had? Five. So that is our, how do you define? Three shirts plus two pants. Is that clear? So this is our addition principle, students. Okay, so what all we have understood here, don't worry, still we haven't started the problems. First, understand the few important things. Okay, don't worry about the permutation and combination, right? So in simple manner, what do we say permutation? Permutation is nothing but arrangements, right? And what do you mean by combination? Combination is nothing but selection. Okay, for arrangements I have given you library, right? You can even take a medical shop also. You can see whenever you ask for a tablet among lakhs of tablets, within no short time the chemist gets you your tablet because they have arranged the tablets in a alphabetical manner in their shop. Okay, and similarly selection is nothing but your fruit juice or drinking milk, right? So in fruit juice, what you doing? There is no particular order. You are just selecting the things. Okay, and for that, and after this we started fundamental principle of counting, which is the basic. It's like cell is the basic unit of life, right? So here the basic unit of life for this topic is fundamental principle of counting. You need to understand addition principle and multiplication principle. Okay, and that I have explained with the same example, but the task given is different here. Okay, so I hope you have understood today's class. In the next class, in the tomorrow's class, we shall start up with the examples and exercise 7.1. Okay, students, now we are open to the doubt session. Okay, one of the student is asking another example on the additional principle. So let's say this is one bag. Okay, so in this bag there are four marbles of red color, right? So it's nothing but I can say R1, R2, R3, R4. Okay, so let me draw it bigger. So this is one bag. So there are four marbles of red color. So let's suppose it's R1, R2, R3, R4. Four red marbles and three blue marbles. So let's do it be B1, B2, B3. Okay. So to understand this, so to understand how to understand this, I have told you permutation and combination depends upon the questions asked. So as for now, I can tell you regarding only picking one item. Don't worry, students. There are some questions in the coming worked examples and exercise 7.1, and you can find some more in the combinations also, where you need to add addition principle compulsorily. Okay, you will understand there how addition is applied here. So this is a very basic example or a basic idea. So begin with pick any one item only for now. Don't worry, tomorrow in the worked examples and exercises, there is one question where you will see you apply addition principle as well as multiplication principle. Since I have not started today worked examples or exercise problems, so that's why I'm not picking up that particular question. So before you pick that particular question, you need to solve some basic problems. Okay, so as for now, so let's understand this concept only, understand addition principle only by the task given. Pick any one item. So now look here. So this bag has four marbles and three blue marbles. So and what is the operation or event given here? Pick any one item. Is that clear? Pick any one item. So here the event of picking four marbles. So how many options do we have to pick four marbles? Right? We have four. Right? Sorry, red marbles. To pick four red marbles, how many options we have? Okay, four. And to pick any one item from three blue balls, we have three. Okay, so the question is pick any one item. That means you can either pick R1 or R2 or R3 or R4 or B1 or B2 or B3. Okay, picking, if you have picked red marbles, there is no need of picking blue marble. Is that clear? If you pick one item from blue ball, there is no need of picking red marble because your task is over. What is your task? One item you should pick. Okay, your task is to pick one item. So either it may be from red or it may be from blue. That's it. So to pick red marble, how many options do we have? Four. And to pick blue marbles, how many options we have? Three. So in how many ways a person can pick one item out of this bag is seven ways. Okay, so when he puts the hand into the bag to pick, okay, he can pick either R1, right, either R2 or R4, similarly B1, B2, B3. So he can pick any of these seven items. So this is nothing but red marbles M. In general I'm talking, okay, blue marbles N. So this is nothing but our M plus N base. And don't need not worry, students, about the same thing what I'm telling, picking one item only. Okay, so as of now for today, understand this one. Tomorrow in the worked examples and exercise, you will find the problems based both on multiplication principle and additional principle. Okay. Okay, one more student is asking, sir, what if there is only one pant? And what if there is only one shirt? Okay, so here you are going to dress up and you are having only one pant and one shirt. Dressing up. So dressing up should complete event will be wearing pant as well as shirt. Okay, wearing pant and shirt. Here both are dependent on each other. In multiplication principle, both are dependent on each other. Everything must be completed. You have to wear a pant also and you have to wear a shirt also. Then only your dressing up is complete. So to wear pant, how many ways you have? One way. You have only one option with you. And to wear shirt also, how many options do you have? Only one. Right. So to wear pant or this event is occurring in one way. Right. So wearing shirt is also occurring in one way. Both, and for dressing up, both must be completed. So M in general way, M into N, right? Multiplication principle. So wearing pant one way and wearing shirt one way is equal to 1. Okay. So let's suppose this is our person, right? So you have made him wear one pant over, right? So you have made him wear a shirt over. He's dressed up now, right? So in how many ways you can arrange one pant and a shirt? It's just one way, P1 S1. Okay.